Today I'm going to continue to work on my linker. So I'm exactly where I left off last time, where I got this game to build or to link called Broke, which is some textual or like console roguelike game. And it linked to this executable a.exe, but if I try to run that, we will see that it says, well, rename wasn't found in the DLL that it was specified in. And this is because the way I currently link everything, I just assume that every import of the binary is in kernel32.dll. So if I do dump bin of a.exe, and I dump the imports, we can see there's only kernel32.dll, and I just assume every import of every procedure is in kernel32.dll. And I thought this would be enough to get like a decent program running, and well, call it quits for this toy linker. But the problem is, to get any real program linking, I need to at least probably have a version of libc, so the UCRT essentially, and kernel32.dll. Otherwise I can pretty much not get anything linking. And when I have two, I can already do like more than two and get it working for real, is the plan. And so for this project that I'm linking right here, essentially I need 4 libraries, I think. If I look at the version that I produced with MSVC, we have this Broke. And if I do dump in on that, you can see we need a vid API or something, user32, kernel32, and then this, all of this stuff is UCRT. I don't know, is there a UCRT.dll? Where, I guess, UCRT.dll. UCRT base, I think. Yeah, so that exists. So I'm pretty sure I can just assume all of these are in the UCRT base.dll. But anyway. So that's the plan. To get this binary right here, which we've linked to instead of when it's doing this. So I built this using the link.bat script, which just takes all of these object files, throws them into my linker, and then produces this a.exe. And so instead of assuming that every import is contained in kernel32.dll, I will now try to make sure to actually find the library. Okay. And I'm still not willing to implement loading of .lib files, so archive files. And instead, I'm just going to use load library to load the DLL and then get proc address to figure out in which DLL the functions are, which is really hacky, but it should be fine. And so I hope then essentially this won't get too much more complicated than what I currently have, but we'll see. Okay. And so essentially what we have to look is everything that says DLL import. And now all of these need to have multiple can be in multiple libraries. You have to figure out in which one they are. So currently I have a DLL import index, and this is global for every of the DLL imports. What I'm just going to do is I will make an array of possible DLL imports or possible libraries, and will linearly scan through these. So let's put this up here. Struct, let's call it maybe just DLLs, maybe. And we are just going to use the C feature where I can not specify an array index. Then we have a char name, and well, we need a handle. And probably this DLL import index. Okay. And then which one did we say we needed? I think this one is the one I care about. So I need with API I need user32.dll. Come on, man. Hands, please. Okay. Grammar32.dll. And then all of these, I think I can specify UCRT base. But we will see if that's true. Then everything else is 0 initialized. That's fine. Then do I have an array count macro? I do. So for, let's call it DLL index, starts at 0, DLL index is smaller than array count of the DLLs. Now we have to fill in this handle, which I am going to use load library. Just making sure the library is loaded. Of DLL index dot name. Then maybe let's see. Maybe try to, it says it's an H module instead. And actually, one thing that's kind of annoying here is because I don't think I used anything so far in terms of Windows things. But I guess this means I need to include windows.h like this, which is annoying. I kind of wish I wouldn't have to do this. Let's say that we want to clean this up and say pass .lib files instead. But for now, let's grind through this. All right, we have all of the handles, hopefully. Let's see if that builds. And it doesn't because I've got a lot of DLL import indices. That's fine. Which is essentially what we want to do right now. So here, where we figure out the DLL import index, what I'm going to do is to scan through the list of DLL imports or DLLs that we have and call get proc address on each. So then DLLs of DLL index dot handle. This is what we have, and we want to call get proc address. So get proc address, which is going to return us after we've loaded the library. We can now get the pointer to the function. And so this should only work out if the function is actually in this library. I think all of these symbols are zero terminated. Are they? Or do I need to copy as well? Yeah, I'm not 100% sure because I'm not sure if these are zero terminated, which is not great. Okay. Let's maybe look in the spec if it says that they have to be zero terminated. Or like the documentation, because it's apparently not a spec according to Microsoft. And these are external or like symbols. So accelerated symbol records, but we want the normal single symbol record. And these have a short name, an array of 8 bytes. The array is padded with nulls to the right if the name is less than 8 bytes long. But that's doesn't necessarily give us a length of a zero terminator for something that is 8 bytes long. Okay. So I guess we need to copy. Are we able to just use the arena here, or is there anything daisy chaining going on? No, I think we can just use the arena, so it's more or less fine. We only need to copy if and only if the string is of size 8. So if symbol name was size is 8, then let's use u8 new, or like char star, I guess. I think I use for strings here is a new data is push data, push array into the arena of char stars and 9. And mem copy into new data from symbol name data for 8 bytes. Make sure the new data of byte 8 is 0, and then symbol name.data is new data. Make sure the string is so. And then if we do that, we can now use it here in any case. So symbol name.data. And what we get back is like one of these far procs. Not here. Proc address is a far proc, but that's just a pointer. So we can check for now. Let's use in like u32 found index 0 is, let's say, -1 and use an int. And if we find this, then we do found index is DLL index and we break. So if we couldn't find it, then maybe let's use a pointer instead. I have to name this type though. Loaded DLL. Good name. One of these DLLs is null, and here we say DLL is this guy right here. And if we found this DLL, then if we couldn't find it, we print error send s is not in any of the known DLLs. Here we can use symbol name data symbol name first the size, then the data. Then at this point let's just return. I guess we can continue. Now let's say reference to undefined symbol is 1 and continue. So that we print all of them and not just the first one. Okay. Could use this is DLL import and say it's an DLL import index instead. Maybe. Can also just put more stuff on to the struct, which is fine. Yeah, let's do that. Instead of being smart. Okay. Now we have this pointer to the DLL, and so I can use it for this DLL import index, which is just linearly allocating indices. So DLL import index ++. And so lastly, on the symbol, we also put the DLL, just DLL. So then going up to the external symbols up here, I can say struct DLL loaded DLL is what I think what I called it, is DLL. Okay, so let's compile that and see the other errors I have. Right here, push array has to be an index to arena. Null is not defined. Well, sure, let's just use a literal 0 instead. DLL import index unequal to 0. Sure, let's just get rid of this check. It's fine. Later on I will need the rdata section anyway for the debug information. So it's fine if I say that this just always exists. Okay. Now we have the DLL import index here. Okay. Now, instead of just having one of these, I have a bunch of these. So we start out with the size at 0, and then it's up there, it's at 0, so for all the DLLs, we add to the size. So DLL information size plus equals the stuff. This is really ugly formatted, so I guess I have to manually do it. Yeah. Maybe I should just put it in one line. Anyway. And then the DLL import index is from DLLs, DLL index, and this value. Next one. Get rid of this again. Write in the DLL import information. Read. Now need to do a little bit more. Essentially, we want to add one to all of these. Just one thing we have to do. But I think I'd rather do that in the loop. Oh, and the size I just specified is wrong because I was counting the null import directory table, and that only has to get added once. Okay, so let's fix up first up the label right here. So this is import directory tables, which is, then this is at 20 times array count DLLs, which means this comes at, well, this plus 20 I essentially have to add instead of this 40 every time. Okay. So before I forget, let's fix up the size I just messed up. right here. Because essentially for every DLL, we need one import directory table entry. We need 2 times the import lookup table, because there's an import lookup table and an import address table, which both have a 0 terminator. And then we need the size of the name hint table, but just one. And then the size not of kernel 32, but the size of the name in the end. So we need this. In the end, we add the size of the name plus, so plus e equals 1 time the size of the null import directory table. And then the size of the name hint table. I think the name hint table is global for all of them. At least can be, because it's RVA based, and I think I already do it that way. Where do I look these up? Let's get rid of the debug code right here. Should be right here. Yeah, size of the name hint table is globally calculated for all of these DLLs. So that should be fine. Okay. So essentially we have the size of one import directory table entry, the size of the import address table, the size of the import lookup table, and then the size of the name, which is strlen of DLLs, DLL index, name plus 1. Okay. So now we have calculated the size, hopefully correctly. Let's try to fill in all of the data. And so we have these import directory table entries. Which is now one for each of the things in the import directory for each entry in the DLLs. So for what am I doing? 32 DLL index equals 0. DLL index is smaller than array count of DLLs. DLL index plus plus. We want to emit one of these. Import table base. Okay. So then the we have to keep track of the size of everything, which means we should emit everything in one go. I think is what that means. Yeah, which makes this also inaccurate. Anyway. Maybe I should, in theory, emit everything in the complete other order. But here we are, emitting it in the wrong order. It's fine. So, we have to fill in the import lookup table RVA, which we said starts out immediately after the import directory tables. And so let's keep track of that. 032, I think. So the import lookup table add or offset base add, and this starts out at 20 times array count of DLLs plus 20, just as we specified above. And so this value can now be substituted in here. And we somehow need the total size to skip past this. So maybe I will keep track of the total size of how many DLL imports there are. So total amount of DLL imports is 0. Here in this loop, I'm just going to add to it. Because then I can already calculate the base up here of the import lookup table. Where it starts is the total amount of DLL imports plus the array count for the 0 terminator, the DLLs times 8. This is the import address table base add. So we have this. We already also have calculated the address table add. And we can calculate the name RVA. Which is this long thing. Then we need to add the appropriate amount to each. So both of these guys, wait, I forgot this is missing here. Okay, that was close. These, we add 8 times the DLL index, DLL index plus 1. And then to the name RVA, we have to add the length of the name. So okay. And in theory, these should now be correct. And probably should fill all of these in this loop because we already have the offset calculated here correctly. Import address table relative virtual address. Okay, so this guy is import address table RVA. Oh, I took that off the entry. That should just be the DLL import information relative virtual address. I don't know why I made this so complicated. Okay. So I want the import lookup table, the import address table, which I'll put right here. And instead of this 40, we need to use these bases. And finally, the name should be at the very end. I do kernel32. Should also get an address, which I guess I can fill in at the very start. So the import name RVA. And I memcopy in from, okay, let's do an U64 name length. Okay, and let's not call it kernel32, but DLL name. Now the name hint table base and name hint table RVA I have to fill in later because these are, there's only one of these and not one per DLL. But I will fill in the name, not the name hint table. Oh, this is annoying. Actually, it's not. It's not, it's fine. I have to take half of this. I actually have to fill these in iteratively. So I cannot use this loop because the way it's structured, I use the DLL import index from the symbol. To fill in the name hint table entry RVA. So what I'm going to do instead is to, well, this copy has to be done for each of them. So I will move this one down and do this copy in the end. But the import address table from the import lookup table. Actually, this also kind of doesn't work to do this mem copy there. What I have to do is I have to cache these indices in the DLL. So I'm just going to say DLL import address table is this, and import lookup table is the same thing. And then maybe I'm not going to even use this mem copy, but just when I'm right here, I have the symbol DLL import index into the import lookup table. The import lookup table is now on DLL symbol DLL right here. And while I'm at it, I can just do the same thing for the import address table. And that should work. So now, going back to the DLL, I have to add these members. So loaded DLL. Now, the name hint table base cannot work off the DLL import index, but the total amount of DLL imports. Oh, it's not +1. It's plus the array count of DLLs. Because each of them has a null terminator. There's not one null terminator. And same down here. Then it's also not 40, but instead this amount. These are quite long expressions for not much, but let's keep going. Name hint table RVA. I don't need this in this loop, right? So let's move these ones down to right here. Where are we? DLL is not defined because it's DLLs of DLL index. Wanted unsigned long given unsigned long star. So I messed up these declarations, I guess. Oh, I missed it up for one of them. DLL index is not a member of structure. Is it this? Oh, it's DLL import index. I think. Raw end, raw vert end are not used. These were probably here before, I assume. Vert start. Do I need any of this? I think this is all old debug code. Yeah. This link, this build. But I feel like there's one more thing I have to do, which is right here when I have the found DLL import. Then I have a found DLL import index. But this is not correct because, while this is true, we also need the virtual address of the import address table. So found DLL import import, what is it called? Something table. Import address. Is it import address table? I think so. Yeah, import address table. Relative virtual address. This boy is also going to be on here. So where we fill these in, so DLLs of DLL index. Right here, we can calculate the import lookup table RVA, or we have already calculated it. Import address table, not import lookup table, importantly. Okay, but from here, missing 8, ending, what's going on? Yeah. Oh, I missed a plus. That's what's going on. Okay. Now, if everything worked out perfectly, we should be able to link and run the damn thing. It says everything is not at one of the known DLLs, which is fine because they still have their -- in dash. So I forgot to get rid of those. So +6. Let's copy one of these while I'm at it. Double plus is not correct. These are our warnings. So it produced an executable. To build the suspense, let's look at it. And we want to see the imports. How good do we look? We have one UCRT base with all of these imports. We have one kernel 32 with all of these imports. We have a user 32 import DLL with all of these imports. Finally, an Advid API with all of these imports. Now, I will try to run it now. This could crash for any number of reasons related to these DLL imports or any other thing really, because I have not really tried to run it at all. One thing that I see though, which is concerning, is that these are not aligned. Probably they should be. But maybe it won't care. Let's just try to run it. Nothing happened. It's probably a crash. But we can see if it actually crashed somewhere or whether or not it didn't even load. Suspended. Can I pause it? No. Continue. And start. Okay. Exception thrown. Right here. Trying to call a DLL import. So that might be related to what we just worked on. So I have this address right here. Memory. And we add this value right here. That is somewhere nowhere. First thing we can check is this like the first instruction? By I think starting at the entry point and stepping in. Yes. So we don't get very far. It's not even trying to index an aligned address to any alignment, I think. Oh no, never mind. 5C. 5C seems fine. Where does it think these are? Something is at 5C. So the entry point of this broke thing is, I had to define myself. So to compile with no default libs, I had to define it myself. So it's in this pre-main file. So we can see what the entry point looks like. It's this start, and the first thing it calls is get command line A. So right here, just some entry in the DLL imports. So what we should see is something in this table. Now, first off, because I find it somewhat suspicious that these values are not aligned, first off, I'm going to align the size of the RData section. Which should be in right here with the total amount of DLL imports. Here we allocate the RData section. And so size of raw data, I'm just going to align. So no, not if we don't have it, but right here. This is itself plus 7 and not 7. Which that crashed it. Oh, that's interesting. Oh, does it crash because I have it running? Yes. Well, I'm not going to investigate that. Who cares? Quality development. Right, this is useful, but that's not what I want to do right now. I want to see, then it's not that useful. Yeah, get it open and be gone. What I want to investigate is now, are these pointers more correct? Is this now 8-byte aligned? No. Then that means that assumedly these descriptors are not 8-byte aligned. Which I guess means this only has to be 3-byte aligned or 4-byte aligned. And we have to add this is plus equals if the amount of DLL imports we have plus 1, then we want to add 4 bytes. Because these are 5U32s, and so it's not aligned in the end. So let's add this here. This is getting way too long. So maybe let's not add it there. I think I forgot the end one up here. Let's call this import table import table end. Okay. Now are you aligned? Nice and aligned. And these still look fine. Doesn't tell me in the slightest why the offset was wrong. But we can now see what this is. It's now 56. Sure. The other address is still the same. You can see it's in 2D5560. It should be in none of these ranges. But maybe the 5560 part. Nope. Let's make sure these are in the RData section. Which I'm not dumping. But they appear to be. (61B) 115 to 61B. Yeah. So I think the next step is to step in and see where that index is coming from. Maybe that is all I need. So where we calculate these offsets should be down here, and I can find it here. So here we iterate all of the sections that are in the that we have to combine. We copy in the section data into the final image data, and then we apply relocations. And this should be filled in by a relocation, I assume. So we have the relocation address, the symbol table address, and the relocation type. And I guess let's just see where these relocations end up. So this should be a DLL import. Let's go to right here. None of them are DLL imports. Wait, halted with 1. Builds. Is the path too long or something? Anyway. Okay. Let's copy that again. Still not. What is your major malfunction? Do I get through this? No. Was it because it was open? No. What is the difference here? Okay. Don't know what the issue was, but I don't care. This should work now because it worked once. So we can set this breakpoint that I just wanted to set even further down. Here where we combine all the sections, we get all the relocations. And we care about the DLL imports. Okay, now we're finally here. So what I calculate is the import address relative virtual address, import address table relative virtual address, which is a bad name now. Which is at 16A0. And then, oh, I'm adding the relative virtual address twice here. So we don't need this import address relative virtual address, which is a bad name anyways, because I was using it for the base of the whole import section. At least that's what I was thinking I was using. This thing, if I remove it from here, is it still, no, and it's only ever written, so we can remove it completely. All right, that feels good. Now, do we work now? I see. Now I filled that into the script. Do we work now? We do! All right. That's what I call success. Can we quit? Can quit. Just using A. So it works. It is linking this correctly. I'm kind of blown away that it just worked. I was thinking we probably had to debug some crashes in some other parts of the code, but I guess all that was missing was the DLL imports. Okay. And again, that this is really slow has nothing to do with my linker, because I don't know, it's the same for Visual Studio. It's just a setup that I'm using. Probably these libraries don't like each other, something. But anyway, that was very good. That worked out very well. Thank you for watching.